So we've got 4 stub shafts here that we need to machine. It's just really just one end that's machined on all 4 of these. And then we've also got a sprocket here that needs to be a new bushing installed. It actually rides on this sleeve right there. You can see it's just wore out. So need to clean it up, machine a new bushing, and that'll take care of that. These guys right here, what we're gonna do is just take 4 pieces of shaft material and turn the ends. So it only needs to be turned on this end here. He said that this area that's turned here is that's not needed for anything. This is not being used, so he just wants the end turned. This is the same diameter, only it goes back. It's about 6 inches on that 7/8 diameter, and then they get welded in, and it's a very slow speed turning application for a roller, and that's why they've been cut out like they have right there. So I'm going to help them get these guys done. I wanted to make this a CNC lathe project. Unfortunately for me, I've been over there trying to figure out the conversational programming again on the CNC lathe. I've been gone for a while, so I'm going to have some refreshing and get over there and get some time on the lathe to figure out how to do even the simple stuff like this and do it efficiently. But because I don't want to spend a bunch of time relearning what I've already learned on the CNC lathe, I need to just get this done. So I'm most likely going to jump over here on the manual lathe, get those 4 shafts turned since it's so simple, and continue learning over there on the CNC lathe. But what I'm probably going to do is go ahead, use this as a practice session. And my friend Steve up at Miltronics, he's going to give me a hand too, is we'll write a simple program for each one of these, and I can definitely go in there and use these as a practice session on the CNC lathe for doing something very simple. I know for a lot of the guys that doing this CNC stuff every day, this is very, very simple for them. But since my mind is always working with these manual machines, I know exactly what to do to come over here, chuck it up, grab a tool, turn it, chamfer it, and I'm done. With the Miltronics, I have to go in and actually program it, whether I'm doing it on the machine or using Fusion 360. And I want to get these done. I don't want to learn on this and try to get it done. I want to get them done and get them back to the customer there. So I'm going to go ahead and start jumping on these and working on them. But as we continue our training and learning, I'm going to show you doing these on the CNC lathe as well. All right, so we're going to get started on it. We've got the material right here. I just cleaned it up because it was kind of rusty there. So 2 different stub shafts that we're going to be machining. The only difference is the length and the radius that's cut into the corner there. So the shorter length is 3 1/16 back, and they only want a very tiny corner radius because they actually like to use the shoulder, the bearing journal that goes up against it. They like to go against that there. Chamfer the corners. And then the number 2 is going to be a longer turn. We'll put a corner radius down in there and chamfer the corners, and that's basically it right there. Very simple turn job. We're going to be using the Precision Matthews today to do this. We've already got one ready to go. And I just wanted to point out, we finally got our very first cool snap of the season here in Florida. It is a beautiful day. It was yesterday as well. The camera is not set to see outside very well, so I'm sure the sky looks white there, but man, it's actually pretty blue skies and the temperatures feel awesome. I love being able to have the door open when I'm in the shop, whether it be this shop or the home shop, working and letting that fresh, cool, crisp air come through the shop, and just really enjoy that and have a little extra light come in. So I'm gonna jump over here on the lathe, get these 4 shafts turned and get them done, and get them out of here, and then we'll work on the sprocket after that. Set our Z, we go with negative 3 1/16. These lengths aren't super critical either. I hit our 0 right there. I need to change direction. $10,000 feed rate, 100,000 to pass. We don't have a lot to come off that. Just go ahead and verify our position. Yeah, so we still got 200 thousandths to come off of it. We're right at the limit of using a live center to support the end, but I think we can get away from it on these. Only about a half a thousandths there. I'm thinking our finished cut should clean that up. Yep. I'm gonna kick it up a notch. One thing I love about this new lathe is we got nice high ranges that run smooth and quiet. This will be 1200. Finish feels nice and smooth. That's that gummy cold roll that we're turning 1018. So once you get down to these light cuts like that, it's hard to get a good finish unless you're really spinning it up fast. Okay, I'm just verifying my sizes right here. Pretty good right here. This should be our finished cut. So by the way, this is the corner radius on this insert that we're going to be putting in that. They requested that. We just called it at 15 thousandths on that corner radius is what we're using. That's what they want. That's what they're going to get. Clean up that shoulder. Another 5 thousandths. And that should put us within a thousandths of being to our size. Yep. So I've got 1 thousandths, and we've got some fine emery cloth that we'll use, and it'll take that down. Plus it's warm, so we'll come back to that and finish it here in just a couple of minutes. Just use some of this 320 grit paper to knock that thowel down. Probably can't see that, but we are just about on the mark. A couple of tenths to go. That's looking good right there. That's looking good. It's still a little warm, so I'm going to give it a couple more minutes, let it cool off, and then recheck it, but we're basically there. If I need to touch it up again, I will, but otherwise this one is going to be done. So I'm grinding a form tool out of a piece of high-speed steel. This is a 3/8 high-speed steel blank, so that I'll have a tool to cut that radius. So I'm just kind of matching this radius right there. That's all it is to it. I'm just going to keep shaping it until we get it to match the radius for the shaft there. All right, we've got our two short turned ends finished up, so we're going to get to the long ones now. We're just going to stick it out about 7 inches. They're turned back about 6 1/8. You guys always like the forge all indicating, so we'll go ahead and show you one of these getting indicated in. Start with the high. Once you stick it in there, tighten up the high spot. And then loosen your lows, and then tighten the highs again. Perfect right there. So once you tighten up your high jaws, usually you can get it pretty close. And when you're within a few thousandths, you should be able to just kind of tighten the high jaw and it'd be really close there. So that's a 1/2 thousandths. We are true. A long stick out there, but we're just cleaning the face up, get rid of that saw cut. Got my Z set to a 0 here, so bring this down to our turn length, but we'll go ahead and drill our center. That center does not sound good, man. That's something that I definitely got to, I can just hear that thing. I got to get me some more centers. That last one that I bought did not work out the way it should have, so I got to get some more of those coming. All right, let's go ahead and get our distance set. I found my other center. I forgot it was in the Miltronics. This is one of my good ones here. This is a Royal Products. I was disappointed at IMTS at their display. They did not have any of their live centers on display there. It was all their more other modern work holding stuff that they make. Now we're ready. Here we go. This is my first finish pass here. After this, we'll mic it and take about another 25 thousandths to bring it to size. $25, $25, and $25. We got exactly 25 to come off that. So what I'll do is I'll take 24 thousandths, and with the heat and a little bit of polishing, that takes that thousandths down. So there's our radius tool that we ground over on the pedestal grinder. I honed it with a diamond hone, so you have a very smooth cutting edge there all the way around. And whenever you feel it with your skin, it should feel very, very sharp like a knife. So that'll work good with a little bit of cutting oil and get that radius cut in there on that corner. Let's see how our tool does. I'm going to use some cutting oil for this. It's doing nice. Just like it should. See if I can blend that corner. We're just about there. That's pretty good. Before I retract the tool, you can usually just feel with your fingernail. And if it's off, it can't be more than a couple of thousandths. There it is, 1 1/1000. That worked out pretty good. Just a hand ground high-speed tool to cut the radius just the way we want right there. A couple of chamfers and a little bit of polishing, and this first one will be done. Break the corner off. Just like that. I'm gonna go ahead and just get this polished off camera. You see me do that. Use the same 320 just to blend it, get that last thousandth out of it. And it was pretty warm too, so it should be cooling down and shrink a few tenths at the same time. So we've got all 4 of our shafts now finished up. They turned out nice. You can see they finished good. Good looking radius there. Everything's blended together well, and they're right on size on our 7/8 diameter journal size there. So what the welding shop's going to end up doing, they've got the CNC plasma table over there that cuts really good. So they're gonna plasma cut these discs and just weld them onto the end. So there'll be 2, be one on the end and then one about right here. They'll get welded on, and then they will stick this back into the tube that they burned this out of. I saw it where they got everything cleaned up, and it's a nice smooth bore in there now. And but anyway, they'll stick these in there and get them welded. They'll probably have some holes back here to do the rosette welds for the back flange, and then a solid fillet all the way around the front flange there. So that's really it right there. It's just a the rollers that these are for, I believe they're sort of like idler rollers, so there's no gear or anything. There's no sprocket that goes on these to mechanically drive them. I think they're just idler rollers. Some more stuff for the linen company. And so that's done on my part right there. So we need to do our sprocket right here now. And this guy right here, I don't know if it goes to the same equipment or what, they didn't say, but anyway, you can see it's got what's left of a bronze bushing in there. It's actually worn through on that side. And then you got the steel bushing that goes through there. So it probably slides onto a stud or some kind of shoulder bolt or whatever, but you can see just how much wear is in that bushing. So pretty straightforward job. There is a turned area right here. So we'll be able to chuck that. We'll just use our 4-jaw chuck and skin this out, make it nice and true. And then I've got a piece of bearing bronze right here that we'll use to machine a new bushing and press it in. And once we do that, this job will all be done. So we'll go ahead and jump on the sprocket now and get that finished up. Okay, we've got our sprocket chucked on that turned hub on the back side there. We'll use our dial indicator with our ID attachment. Since we've got, I believe this is machined on this side as well. So I'm just going to use this ID attachment to actually come and let's get this straight. I got the ball sitting right there on that on that little shoulder. Get this around here where it's a little bit easier to read. All right, so the low, push it that way. Loosen up that high spot there. Wrong way. Just trying to tighten the, so I'm on opposite side of the needle there, tightening the lows. So wherever it falls to the lowest side, just try to get it right there. That's high, that's low. Just a little bit of torque. I'm not trying to over tighten it and warp the bore there. Once we get this trued up, I'll spin it up, and you can usually visually see whether you're running true or not, but I would assume that this journal is machined true with the sprocket since we have wear in the bushing right there. Now if you can get the bushing out of there, you can re-indicate that bore where it hasn't rubbed on it. That's pretty good. I'm going to go ahead and move our indicator off out of the way. And let's, where are we at? 2. Usually it's a little easier to spin it up a little faster. You can kind of see. Looks pretty darn true to me. I'm standing here looking at the face of it too. I don't see any face run out. So that looks pretty good. So we'll use we'll set up a little carbide bar, maybe something like this guy right here, and go ahead and use it to bore that bronze bushing out of there. All right, we got our, I put a shorter carbide bar in there to do this, so see if we can get her done. Really just want to cut this out and clean the bore up at the same time. It looks like that was oil impregnated bronze. There it is. Let's see if we can, that's what's left of it right there. So we still need to take a few thousandths out anyway. There's one little spot in there that's not cleaned up yet. So we're just going to use a telescope gauge here and a mic and see where it's at. We just want to kind of land on some kind of even numbered size, you know, instead of just shooting in the dark here. So that's at 125, 678, so about a 1 inch 128. So I don't know. I just want to clean it up to make it sort of like an even number. What should we make that? I don't know. How about, I don't think we need to take it out to 150, but how about we make it 135? So that'll be 5, 6, 7. Let's take another 7 thousandths and see if that will clean it up round. There's 7 thousandths. Let's see what that looks like. Yeah, it sounds like it's cleaning it up nice and round, so we'll probably just leave it right there once it's finished with that cut. That's cleaned up nice and round right there. So, and that's definitely cast iron sprocket. Just want to chamfer that corner there. The other side I'll just do with the Noga deburr tool. Just like that. Take a little piece of emery, just break the sharpness off of the chamfered edge there. Let's see what we landed on. I was shooting for 1 inch 135. Let's see what we got. Right on it. 1.135. So that'll be our OD, nominal OD of our bushing with enough interference to cause it to press in there. And so that's what we'll start on next. Let's take this out. Start on our bronze bushing stop. Use our telescope gauge. This is going to be my final cut in there. Just matching it up to the steel bushing that this bronze bushing is going to ride on there. So we'll just make one little finish pass through there, and that bore will be done. All right, that should be good right there. Just trying to give it a 2 to 3 thousandths clearance over the steel bushing once this is pressed in there. And it's not nothing super critical either, just an idler. I got it right there where I want it. All right, so we'll turn the OD, get our chamfers on there, part it off, and the lathe work will be done. Just using the brush here, kind of deflect the chips somewhat. Keep them from spraying all over the place. Another trick you can do that I've done in the past, and I've been meaning to, need to get my shim stock back down here. You can make you a piece of shim, bend it, and clamp it down to this screw right here on top of your tool, and it's a easy little shield to make to block the chips. If this works right here, it just kind of blocks the view of you guys. But just some simple turning right here. Take it down a few 100 thousandths, chamfer it, part it off. All right, we got our OD finished with 1 thousandths press fit. We've got our distance set. We're ready to part it off. I went ahead and turned a 1 thousandth step smaller on this end to help align it once we press it into the sprocket as well. And it's not very thick, so I'm gonna use the old plastic Sharpie here to catch it. That tool is acting like it's high. Now the camera's in my way. This is how it goes. Camera's always in the way of my tool post here. And drop that down a little bit and see. And while we're at it, let me get my file over here. And we are going to break that sharp edge on that side. Let's try this again. I know what it is. I think that tool's dull. I looked at it, but all right, I need to go sharpen it. I think it's got a flat spot right on the cutting edge there. Let's try it again. Sharpen that up. That's better. There it is. Just got to deburr that one inside edge, and it's got to be ready to press in. This is the steel bushing that is going to be riding inside the bronze bushing, and I realized that the outer edge of it right there had a little bit of, it was flared up just a little bit on that end. Why, I don't know. Maybe all the wear is just back here because it's not consistent, perfectly round. There's definitely wear on that, but anyway, just chuck this up in the forge. I'll indicate it. Been using the smooth file and just trying to hit just that end right there, and I think we got it. Got our bronze bushing, and it fits on there now. So I couldn't get it to start right on the, it was right on the edge that it wouldn't go on there, so I think that's going to work pretty good right now. But I'll take some Scotch-Brite, some emery paper, go ahead and finish kind of polishing this up, And then the last step is basically just to press this into the sprocket. Since I don't have any kind of press here in the new shop yet, we're going to be taking this to the home shop so that we can get this pressed into the sprocket there. So a thought occurred to me, why don't we go ahead and use our Wilton vise with our new brass soft jaws to try to press this bushing into the sprocket. So I went ahead and I pushed it in. I told you I turned it down about a thousandths so that I could get it started. And I think since we've only got a slight amount of press on this, this might work right here, especially since I've got these soft jaws in there and it shouldn't mar it. So I'm going to put it this way. That way the fixed jaw is against the bronze. Do it this way so I'm not blocking the view of the camera there. All right, it looks like it's working. You guys see that okay? Getting a little tighter. I think we're gonna make it though. All right, guys, well, this job is all finished up, my end of it anyway. There's still some more to do. As I said in the previous video clip, the welding shop is going to be burning out some steel disc on the plasma table, and they will weld these guys. They'll get them all welded on and then put into the tube and get them welded in place. So that's their end of the repair job there. The little bush for the sprocket here worked out pretty good, and I'm glad I thought to look at the Wilton vise there. It did a good job having those new soft jaws in there, getting this pressed in and getting that done. I want to acquire a nice hydraulic press for the shop. That's one of the machines that's still on my radar that I haven't looked for yet, but I really do want to get a good hydraulic press in here. Jobs like this, you know, every shop needs a good hydraulic press for doing things like this. If you got to press bushings or you got to press things apart, or we want to broach a keyway, things like that. That's why we need to get us a press in here. So hopefully in the near future, we're going to be finding us a good hydraulic press. Been looking at the Dake hydraulic presses on their website, and maybe we're going to get us one of those to in here in the shop. But anyway, this job is complete on my end, and hopefully you enjoyed watching this little project. Whenever I got back from our big trip up IMTS in Michigan, you know, I called Joe as soon as we got back and told him I was here if he needed anything. He says, matter of fact, I got a couple rollers over here in the shop that we got to work on. And he asked me if I could help him at least with the shaft work right here. They were planning on getting the rest of it done anyway. So I'm sure there's going to be some more projects come up pretty soon, because they seem to be getting quite a bit of jobs over there that require some type of machine work for them. And, you know, it's handy for me to have the shop right here. He comes around and gets me to do this stuff. But so anyway, this is it. Hopefully you enjoyed watching, and come on back. I'm sure we're going to have plenty more projects coming up in the near future. I've got my American pacemaker compound parts over there. I'm wanting to get back on that job really, really fast. I want to get onto that, but things like this come up, and you know, this takes precedence over those personal projects. But hopefully we're going to be getting to the American pacemaker soon, because that's on my radar. I want to get that back together, and I want to get that lathe fired up so that we can start making some chips and seeing how that lathe is going to perform, and have it ready for other jobs like this that come up that we need the big lathe for. So anyway, hopefully you enjoyed. We'll see you on the next video.